Let me begin this session by asking you a question. When did deep learning start? Many of you who might have followed the news in the last decade, they think it was around the beginnings of 2010s, maybe 2011-12, when AlexNet was really good in object recognition and overpowering, becoming better than the state of the art. But it was way earlier. Was it maybe 2006 when the American trio developed first methods to make deep learning in many, many layers of neural networks possible? The answer is it was way earlier. Already back in 1980, a Japanese researcher called Fukushima, he had ideas of making deep neural networks learn, and he used sometimes even this term deep learning, and it popped up here and there in different papers. However, the real big commercial breakthrough was around 2010-12, when these deep neural network architectures overcame and outperformed existing methods in computer vision. So you have a data set of thousands of different classes, millions of images inside, and these images are sometimes simple classes like dogs, cats, airplanes, but also specific ones. There were 150 breeds of dogs in this data set. And it's very hard for people to develop algorithms working on this data, but it's also hard for a common person to recognize all these 150 dog breeds. And in fact, deep learning methods were so successful that they reduced the error by half. And nowadays even by around 10 times. So we have really, really good methods on object detection nowadays. But interestingly, another commercial breakthrough which didn't go so much through the data media was long short-term memory networks. These were other deep learning neural networks. You will later know what this means, recurrent neural networks. They work more on sequences. And they have been developed in 1997 and 2001, a bit improved. But practical applications in speech and handwriting recognition came then 2005 and 2007. And I personally was involved in the one in 2007. So there were commercial handwriting recognition systems. So you write something on a computer screen with your finger or with an electronic pen, and the computer tries to recognize what did you write. And before I did my PhD thesis, these commercial systems sometimes worked well, but specifically on handwriting of medical doctors and so on, they dramatically failed. And then we applied LSTM and other methods, and we identified that they are way better than any other system. And later on, these methods were implemented in handwriting and OCR, optical character recognition, but also in text translation and so on. Nowadays, even more powerful, more deeper architectures like transformers are used for ChatGPT. But what is deep learning? Deep learning refers to very deep neural network. So technically, a neural network which has many, many layers. But deep learning also refers to learning higher level representations. So we have pixels in an image. And at the end, of course, at the highest level, we have classes, the class dog and cat. But learning something in between, like constellation of two eyes next to each other, represent a face, and that could be a face of a cat or a human or a dog. These higher level representations, automatically learning them, that's part of deep learning. Or learning long sequences. What does it mean when I have this handwriting recognition and you have this character L, the beginning and the top and the end of the L, where is which part, how do they belong to each other, and when do we know it's a character L? That is part of deep learning as well. And now we had images and we had sequences, but in general it's any n-dimensional relation of any concepts. You can think about a database of knowledge where you have many different classes, very complex, related to one another, but having now neural networks or deep learning algorithms which make sense of these concepts and learn pattern in those, without a human having to define when this happens and this, then that comes, but the machine automatically learning. That is the constellation, the structure, which finally results in this behavior. So these interpretations of deep learning are all valid interpretations, and we will look into some more details how deep learning works in the following sessions.